The last section covers question number 7. One of Sarah's customers designed the rhombus-shaped kite that looks like such. The length of the spine, AC, is 28 inches, and the length of the spar, which is DB, is 24 inches. A. Explain how to find the perimeter of a kite if the lengths of the spine and the spar are known. Include properties of a rhombus in your explanation. B. Use the Pythagorean theorem to find AD and then find the perimeter of the kite. So I'm going to go ahead and give you about 7 minutes to work through question number 7 completely. Go ahead, take your 7-minute time limit. Pause your video now. All right. As you recall, back in Unit 2, we learned a couple of things about rhombuses. We know that the diagonals bisect each other. So that means that this full length is cut into 2 equal pieces. AC's full length is cut into 2 equal pieces. We also know that with rhombuses back in Unit 2, we discovered that all sides of the rhombus are congruent. Well, if we know that AD is congruent to DC, which is congruent to CB, which is congruent to AB, we can simply take one of the lengths, if we can find one of them, and multiply it by 4 to get the perimeter of the entire kite. Now, Part B asked us to use the Pythagorean theorem. In my paragraph explanation here, I said DE was equal to 1/2 of the full length, so it equaled 12. I said AE equaled 1/2 of AC, which was 28, so that equals 14. So I marked those accordingly here. Well, we know that's a right angle, so I can use Pythagorean theorem. So I have leg squared plus leg squared equals the hypotenuse squared. I got 340. So whenever I did the square root of 340, that was approximately 18.4 inches. And if that's the length of one of these, that's the length of all 4 of them. So I did 18.4 times 4 to give 73.6 inches for my perimeter. On to the wrap-up of this lesson.